Okay, so we have section 2.2, question E29. This will be a bit shorter video. We have the shape of the distribution in each of these histograms. So here in A, we have this familiar mound shape. Things are piling up in the center as if you dumped a whole bunch of dirt and it runs down the side, bell curve, if you will. The symmetric, of course, just means that if we drew a line right through the center, we could fold that distribution in half and it would line up. So going out from the center, we're getting roughly the same distribution as we go away from the center. Skewed right here, again, when we have a skew, we're looking at where the long tail is. So that is on the right side. So this is skewed right. C here is skewed left, the tail is on the left side, and then finally D is a relatively uniform distribution. So knowing the difference between a normal distribution and a uniform distribution does tend to have be very important in a lot of statistical analyses. For example, if you're rolling a dice 1,000 times and recording the 1, 2, 3, 4, 5, 6, that would be fairly uniform. Whereas if you're looking at heights of every male in the US or of every female in the US, that would be normally distributed. And the things that we're learning about z-scores and how much of the data, 68% of the data within one standard deviation of the mean, that's all applying to specifically normal distributions of data, but there are many other types of distributions such as uniform, so just be aware of that. And then we have to match each histogram to its box plot. The easiest one might be to pick out the uniform right away. So in a uniform, we're going to have roughly the same amount of data in the lowest 25%, the second lowest 25%, second highest 25%, and the highest 25%. So that distance within each portion of the box and within the two whiskers should all be relatively the same in a uniform distribution. So D will match up with box plot 1. Then you can see that these two are not very symmetric. You can see that this is their median. Their median is pushed off well to the side of the distribution, whereas this one is centered up quite nicely. It's symmetric. So we know that this histogram A here is matching up with box plot 3. So then we get to these two. We can clearly see that most of the data here in histogram B is on the left side, whereas here it's on the right. So how would we figure that out? Well, here we're getting most of our data. 75% of our data, in fact, is between this 23 and 34 or so. That's the great majority of our data between those two numbers, so that clearly matches up with histogram B. And then similarly, here we have 75% of the data, 25, 25, 25. That's coming in around 40, looks like 46 and 59 or something, which is similar to what we find here in histogram C.